Numbers and basic algebra is the title of the very first topic covered in maths and algorithms. Here we are going to tackle the concepts you are most likely familiar with, but it could be the case that you've forgotten them due to the gap in education. Some of you, I am aware, that might not have studied maths for 4 years, 3 years, 6 years, whatever it is, so hopefully this topic and the video itself will refresh your memory of that. This is the very first topic which will also be included in your test. So please pay attention to everything discussed here. Make sure that if anything is unclear, you are going to email me or your tutor. Now, the objectives for this week is to use elementary arithmetic to solve mathematical problems, namely use simple operations like addition, multiplication, division and subtraction. Then to solve problems involving ratio, decimals and percentages. So a little bit of each. How do you ensure that you know the percentage difference? How can you spread out a various thing according to the ratio, etc. And finally, to understand basic algebra and to define real problems using equations. Within that, we are going to focus on quadratic equations, how to find solution to those. So have a look at the entire video if you can, but make sure if you are familiar with some concept, just skip through them, go to the next part. Let's start very gently with BIDMAS. So I'm sure you have heard of BIDMAS before as well, but the chances are you have heard of BIDMAS in your own language, which is fair enough. In English, BIDMAS stands for brackets, indices, division, multiplication, addition, and subtraction. In other words, we are talking about the order of performing operations. We need to know what action has to be taken before another action takes place. It's very similar to what you do when you're trying to write a program. You need to understand what a given variable might hold at a given time before another operation on that variable is being performed. Here, in mathematics, in the simplest terms, we are talking about BIDMAS. So you have to evaluate anything in your brackets before you start multiplying. You have to perform all the multiplications before you start subtractions or additions, etc. Bear in mind that in this acronym, division and multiplication are together, and addition and subtraction are also together, they are joined. What I mean by that is that they are on the same level. Whether you do division followed by multiplication or multiplication followed by division, that makes no major difference, similar with addition and subtraction, because these operations are effectively inverses of one another. Now, sometimes looking through the literature, you might come across BODMAS instead of BIDMAS. The only slight change is this O instead of I. This is to reflect that indices are sometimes referred to as order. So x to the order of 2 is the same as x to the power of 2. And here, similarly, it can be called PEMDAS, mainly in American books or American websites. They can call it PEMDAS. This stands for parentheses instead of brackets and exponentials. So this is the exponent of x to 2. Okay, so just be aware of that. Now, with many of these little concepts, which might not seem difficult at all, maybe they kind of seem a little bit too easy at the moment, but nonetheless, what we are going to do is to give you an example. So I'm just going to solve and talk you through an example of each concept, and hopefully that will make it absolutely 100% crystal clear. Now here we have just a long operation on numbers. No fractions, nothing fancy in there. What do I need to do first? How do I tackle it? Well, according to BIDMAS, I need to look into the brackets. So first of all, I need to evaluate anything that's inside of this bracket. But inside of this bracket, I have another bracket. Okay, so I need to take care of that first. 6 multiplied with 4 is what happens inside of the little bracket there. So 6 times 4, I'm sure you appreciate, is 24. Then the rest remains as it is, so let's just rewrite everything that was in there. So we had here plus 1 divided by 3, we had division 36, also 3 minus 2 in that order, and then 2. So again, I need to evaluate the bracket first. Inside of the bracket, I need to take care of division and multiplication. First, I have a division here, so 36 divided by 24 has to be performed before any addition or subtraction. 36 divided by 24 is 1.5. Okay, I still have the other operations and other numbers intact as they were. So let's just put them in. Okay, so everything's as it was, except that this operation has been performed. Now, everything else inside of the bracket is either addition or subtraction. Because they are on the same level, I'm just going to do them from left to right. 2 minus 3 is negative 1. Negative 1 plus 1.5 is a half. Half plus 1 is 1.5, and that is 2 multiplied with 1.5 divided by 3. And if you listen carefully to what I just said, I said 2 multiplied with 1.5, just to remind you that if you don't see any mathematical symbol between the number and the bracket, all you have to do is to multiply them. So again, because division and multiplication are on the same level in terms of their importance, let's just do them from left to right. So 2 multiplied with 1.5 is 3, and then we are left with divided by 3, and that is of course 1. 3 goes into 3 only once. So all this just to get number 1 at the end. And technically speaking, you should have equal signs all over to say that you are continuing your thought and you are actually doing one operation all this time just to find the solution of 1. Moving smoothly to percentages, let's just calculate percentage of a particular sum. So the question is, what is 40% of 250? There are many different methods. You might have your own favorite. The usual method I go with is to turn percentage into decimal. So this will be 0.4. Why? Because the percentage literally means 1 of 100, percent per 100. So if you have 40%, you have 40 over 100. And if you divide that through, that is 0.4 or 0.40, 40 hundredths, 2 positions after the decimal point. Okay, back to the question. 0.4 of in mathematics translates into multiplication. If you have 2 baskets of 5x, you have 2 times 5 means 10x, of course. So 40% of 250 is 0.4 multiplied with 250, and that is 100 pounds, in fact. Okay, so make sure you always complete questions like this with correct pound symbols or any monetary symbols, in fact. Okay, other method to calculate this, okay, if you fancy something different, you can say that 100%, your absolute everything is 250 pounds. You're looking for 40% of that price, and you want to know how much is that. So you stick in a favorite letter of yours. I'm using N by default, and it could be X, could be Y, could be anything. And then use what we call cross product to work it out. So going across from N, not up, not left or right, nor down, just across. Okay, across we have this 100, circle it, and the method of cross product means that N, the solution N, is being found by multiplying the numbers you haven't crossed together, or you haven't circled. So you have 40 multiplied with 250 in there, divided by what you circled. So in this case, 100. So here, what we would end up with is 10,000 divided by 100, and if you take the zeros out, you will find that this is indeed £100 to reach the same solution. It's up to you what method you use, just to make sure that you understand this in this module overall, not only in this topic. I don't really care what method you use, as long as you can display some sort of logic behind it, so you can show your steps and apply it correctly. I'm fine with this. In any test or exam you do in maths and algorithms, the method, the choice of the method is yours. It doesn't matter. Just reach the right solution, show me some steps. Okay, now let's just do one more on percentages. How much for a product that used to cost 170, but its price has been reduced by 21%? This is very much the same problem in the nature. So what we can say straight away is that I'm looking at 0.21 of 170. Okay, so I want to know the reduction of that much from 170. So what is this? 35.7. So 35.7 is the reduction on $170. It's a reduction, but it's not the full answer. What we need to take is to take this 35.7 away from the original price 170 to give the final answer of 134.3, except that this is not the perfect answer because we are talking about dollars, so dollar sign need to be applied, and more than that we are talking about money, so it's $134.30. So fill in your number with additional 0 if there is a need for it. Okay, so you basically need two numbers after decimal. A bit faster way to combine these two lines together is to do this. So instead you can just think about, okay, I'm taking 21% from 100%, so I will be left with 79%. Okay, you can do it in your head basically, and then just do 0.79 multiplied with 170, which gives you 134.3 straight away, and then you just fill it in with a 0 and with a dollar sign. That's it. Okay, so again, more exercises coming your way in the seminar. Ratio is the next little subtopic that I want to discuss. So ratio is usually expressed as one number to another number. You probably are familiar with a ratio of 4 to 3 or 16 to 9. These you would have seen when talking about resolution. So it tells you how many pixels of width for pixels of height. Okay, so that means for any 16 pixels horizontally, you have 9 pixels vertically. This is just the aspect ratio. This is just to compare quantities in the horizontal with the vertical, or in fact between any two quantities. So typical questions could be along the ways of, okay, we have £2,000, that's the lottery jackpot, and it's being spread between 3 friends, let's say Ali, Betty and Charlie, in the ratio 5 to 12 to let's say 3. Okay, and then how much does Betty get? That's the question. So you can see that Betty gets 12 out of how many parts? That's the question. So we have 5 plus 12 plus 3. That points towards 20 parts. Okay, 20 shares. Betty gets 12 out of 20. so that means she gets 12 out of 20 of the total price, 2000. You can do your magic with division, with simplification here, so that becomes 1, that becomes 100, so you have in fact 1200. So Betty is a happy girl getting 1,200 pounds, and fill it in with pounds, of course. Okay, so this is sort of the things we are going to do. Let's just practice with one more exercise here. We have a price of 900 pounds this time, split between 4 friends in the ratio 3 to 2 to 4 to 1. So again, just pay attention to the language that I'm using. The colon, the 2 dots, means 2, so I'm just comparing who gets however many shares. How much will they get? So with 3, 2, 4 and 1, if you first of all add them together, you will work out how many shares you have in total. So we have, I believe, 10 shares. Yep. So 10 shares or parts, doesn't matter how we call them. Shares, just make sure you spell it correctly once you call it one way or the other, unlike me sometimes. So you have 10 shares, 900 pounds to split, so 900 pounds divided by 10 shares means there is 90 pounds in every share. Well, how much do they get? Each of them, well, one person gets 3 shares, another gets 2, somebody else gets 4, and the unluckiest person gets 1. 3 times 90, 2 times 90, 4 times 90, and 1 times 90 will tell us how much each of them will get. Okay, so just multiplying the number of shares by the size of one share. So here we have 3 times 90, 270, and 2 times 90, 180, 4 times 90, 360, and 1 times 90, of course, it's 90. To double check no mistakes have been made, add up all the numbers here, so all the solutions, it should come back to the total of 900 pounds, which I think it does. So, hooray, we haven't done any mistake there. So, simplistic approach to any ratio question is to add up the number of ratios, work out the price or the size of one ratio, and then multiply by the number of ratios somebody else has. Just be careful, because some of the questions can tell you that, let's say, this 900 pounds is actually what this person gets. In which case, if 900 pounds was equal to 3 shares, okay, let's imagine that other scenario. So 3 shares is 900 pounds, then 1 share is 300 pounds. Okay, I just divided both sides by 3. So that means, for example, that that second person would get 600 pounds, and that person will get 1,200. So I hope you get what I mean in there. If unsure, please ask me a question. Okay, my email is available on Moodle page and in the introductory video as well. Okay, so moving on to the last bit, which is the basic algebra. And when I say basic, I mean really basic, as much as we can, of course. So let's first of all define few terms that are important. A variable is just a symbol representing a number. So it's a placeholder, so a value holder, so some sort of a value is being hidden in there. In terms of programming, I'm sure you can understand by now that a variable holds specific value in the memory of the computer. Similarly here, a given number is being held as a variable. And instead of giving some sort of predefined names like you do in programming, we just used single letters to define these variables. So here, this could be any letters of an alphabet, whether it's a smaller letter or uppercase letter. It can be a Greek letter most of the time, so you can have your epsilon, your theta, your gamma, your omega, your theta, any of those, your lambda. You will see many of those. So I will pretty much teach you Greek alphabet in the first few weeks of this module. Expression is a statement made up of one or more variables or numbers joined together with one of those arithmetic operations which you would have seen at the beginning of this video. So if you have, for example, x plus 5, this is an expression. I express particular value that I have in there. 12 gamma minus 3 epsilon plus half of theta is another expression. I'm just expressing that something has a particular value. When two expressions are joined together, then we have an equation joined with equal signs. So here I just joined the two expressions I have given you already, and I say that these have to be equal. They have to be balanced. And most of the time, real-world scenarios or problems are being described mathematically by variables and by expressions, in which case they are turned into equations, and then equations have to be solved. We have to find out specific values that satisfy the equations, that make it correct, that make it balanced there. Another equation, an example of it, 19y squared x plus 2x to the power of 3, or x cubed if you like, minus 3y squared equal to 0. And then y and x have to be found. And that's something we need to focus on. However, we are going to focus on sort of familiar equations, or when I say familiar, I mean something you would have studied before, or something that is relatively simplistic. So here what we have first of all is an equation, and you can see it's an equation in y variable. There's no other variables involved, just y, and it's a linear equation because there is no squares, no cubes. Variables are not combined with one another. We have a linear equation therefore. Okay, so here what we want to do is we want to shift everything that has the variable on one side of the equation, and then shift everything that doesn't have a variable in it, or it's not multiplied with a variable there, move it somewhere else. So let me just highlight terms, okay, that have the y variable in them. So this certainly has y variable, so does 3y, also 9y, and this term will have y in it. Now the thing is with this equation is that we want to get rid of the bracket first, purely because the bracket contains a term in y and a term without the variable y. So we want to just expand it first before tackling and solving this to the full. So let's just rewrite what we had originally. So y plus 3y plus 5, this is equal to 9y. And then, like I say, this is multiplication of 2 and a bracket. Okay, if you don't see a symbol, that's a multiplication that is going on. If that happens, if you have a number in front of a bracket, you have to multiply each term inside of the bracket. So you have minus 2 multiplying 12, giving you minus 24, and also minus 2 multiplies 3y to give you minus 6y. Okay, so just be careful about those minuses. Minus 2 multiplies 3y, so that becomes minus 6y. So now, moving these terms, so these ones that I highlighted originally, move them to the left. And then this plus 5 will move to the right at the same time. So on the left, I still have y, I still have 3y. Okay, so that's on the left hand side. Now I want this 9y to be transformed to the left hand side. It was positive 9y, so now it becomes negative 9y. Okay, so it changes the sign when we move it across. So positive 9y becomes negative 9y. Similarly, minus 6y, when I move it, it becomes positive 6y. Okay, again, it changes the sign that it had in front of it. Then I have my equal sign, which sort of divides the problem into two parts. Then on that right hand side, I had minus 24, which stays where it was, as well. I don't modify its symbol. And then plus 5, when it moves across, it becomes negative 5. So overall, on the right hand side, if you think about right hand side only for now, this will be minus 29. What happens on the left though? Everything is in terms of y, and when that happens, what we can do is we can take y outside of the bracket and just think about all the terms if we divide them by y. So y divided by y is 1, 3y divided by y is just 3, minus 9y divided by y is minus 9, plus 6y divided by y is plus 6. So you might ask yourself, why? Why have I done this like this? Well, I just wanted to show you a justification of what we call grabbing like terms together, getting like terms joined together. So everything is in terms of y, so I'm free to just take coefficients, which are numbers in front of the variable, and just manipulate them together. Okay, so overall I have 1 plus 3 minus 9 plus 6, as you can see in the bracket here. So 4 minus 9 is minus 5 plus 6, that's just 1. Okay, 4 minus 9, just to double check, because I don't trust myself too much, that's definitely y, 1, sorry. 1 times y, which is just y, so y is equal to minus 29. Which I encourage you to use this, plug it in right here at the very top, and those two sides should be equal. Just pause this video, check for yourself that if you plug minus 29 in these 4 places effectively, both sides of the equation will have the same value. Now, one more, now involving a quadratic. So it's no longer a linear equation, it's non-linear, it's quadratic, order 2 if you like. So how we are going to solve it is slightly different now. So what we want to do with quadratic, as soon as you see power of 2 in one of the variables, is to actually shift everything to the left hand side so that on the right you have 0. So I have on the left hand side, I have this x squared still, I have minus 6, now x, if I shift it, it becomes minus x, and minus 4 becomes plus 4, and that is equal to 0. And also minus 6 and positive 4, they are both just numbers without any variables, so I can join them together. So in other words, I have x squared minus x, and then minus 6 plus 4 overall is minus 2, and that is equal to 0. This is the quadratic in its normal form, okay, in its usual format. I have something in x squared plus or minus something in x plus or minus a number on its own equal to 0. That's the general format of a quadratic. And from there on, there are 3 major ways to solve this quadratic. Again, just to reiterate, you are free to choose whichever one suits you best. But you should be aware of all the approaches. And in fact, if you are comfortable with them, you should choose between one or the other depending on how difficult your quadratic is. One of the methods I want to display on this example is called factorization of a quadratic. So when I factorize, I want to find 2 numbers that will be solutions to my problem. Now, I'm going to do it first, and then I'm going to talk you through how and why this worked. So I claim that x minus 2 and x plus 1, if these 2 values in brackets are multiplied, that's give me 0. Okay, I factorize this quadratic into these 2 brackets, and then I can say if x is actually equal to 2, imagine if that was 2 minus 2, that's 0, 0 times, I don't even care what that is, 0 times whatever is 0, or x can take a value of minus 1. Okay, because in this bracket minus 1 plus 1, that's 0. 0 times, I don't care what is here either, is equal to 0. Okay, so these are two solutions, and you can check in the original equation. If you plug in 2, for example, 2 times 2, or 2 to the power of 2, which is the same thing, which is 4 minus 6, that's minus 2, and then 2 minus 4 is minus 2, so the equation holds. If I plug in minus 1, minus 1 squared means minus 1 times minus 1, that's just 1, minus 6. So 1 minus 6 is negative 5, and here minus 1 minus 4, that's also negative 5. So certainly 2 and minus 1 are solutions, which is backed up by my factorization. But how did I factorize? Well, we need to sort of step back a little bit and think about what happens if I have a particular number with another number, let's call it A for now, and the same number that I had originally plus another number, let's call it B. Okay, so we have x plus A and x plus B multiplied together. If we have two brackets like that, what we have to do, okay, similar to what we did here previously, remember we multiplied that number from outside with everything inside. Here we have to take whatever is inside and multiply with everything that's inside of the other bracket, so that x is multiplied with x, but also with a b, and that a must be multiplied with x and also with b. So what I'm saying there is that x times x, this is x squared, okay, by definition, x to the power of 2 is x times x. X times b, okay, let's pretend everything's positive for now, so that's plus bx, okay, and then what we also have is a times x, so we have plus ax, and finally a times b, so plus ab. Okay, just to collect like terms together, we will have x squared plus a plus b multiplied by x. Okay, this hopefully is not strange to you, because if I have bx plus ax, it's similar to say I have 2x plus 3x, which is 5x. Okay, it's just that instead of specifically telling you this is 2, this is 3, or in fact that these are any specific values, I'm just calling them by random letters, okay, and collecting them together. I'm collecting like terms like I did previously, and also like it is intuitively. Think about it, 2 apples plus 3 apples is 5 apples, so it should make sense. Nonetheless, I collected that, so I have 2 plus 3, imagine that, or a plus b of x, plus ab, and now if you compare for me, okay, now I will just highlight that, this format of my quadratic, of my problem, and this general format without using any particular numbers. So what we find is that we have x squared, which is there, x squared, plus some number multiplied with x. So what is this some number? Well, this some number is actually minus 1 in front of x. It's minus 1 multiplied with x. Okay? And here we have a times b is minus 2. So minus 2. Okay? So what I'm trying to do, and bear in mind I've done it very quickly in my mind, you can write it out if you wish. I'm trying to find out, once I have this normal format of a quadratic, I'm trying to find out two numbers, a and b, such that if they are added together, a plus b, they have to be, according to my quadratic, minus 1. And if I'm multiplying two numbers together, this a and b, okay, so a multiplied with b, this is the number on its own, so according to my quadratic, that has to be minus 2. So what two numbers and bear in mind they have to be whole numbers. Okay, what two numbers are being multiplied together to get minus 2? There are two options, if you think about it. You can either have minus 2 times 1 or minus 1 times 2. Nothing else will give you negative 2 if you only consider integers, which are whole numbers. Okay, if you do this, then both of those will yield minus 2, but that's fine. But then if you accept minus 2 and 1 to go in there, do they add up to give you minus 1? In this case they do. Minus 2 plus 1, it is minus 1, so it works, and that's precisely why I have chosen minus 2 and plus 1 to be my A and B. That's why I substituted them in and put it in that format. If you check the other pair, minus 1 plus 2, that's actually positive 1, which is not negative 1. It doesn't satisfy the quadratic, so it cannot be the solution, etc., etc. So only minus 2 and 1 work, in which case I find out that the solution is 2 and minus 1 respectively. Okay, so hopefully this makes a little bit of sense. It will be explained in more detail during the lecture. Let's have a look at one more quadratic, but this time let's apply a different method. Let's see if you like that one a bit better, a bit more. So here we have lambda squared plus 2 lambda minus 8 equals 0. Before any questions are being asked, yes, if that's your test or exam question, you can change it to x if you're more comfortable, but then at the end you have to say lambda is equal to whatever you found, not x. That's the only condition. Otherwise, try to stick what I'm giving you there. Okay, so let's just do it in two methods actually, just to display the whole range of 3 methods that will be introduced. Second method is called complete the square. So in complete the square, I have to follow almost an algorithmic approach to it. You can call it an algorithm really, because algorithm is just a set of ordered instructions, and this is certainly a set of ordered instructions. Instruction number 1, look at the coefficient of lambda, so again the number in front of lambda, divided by 2. So this divided by 2 is 1. So what you need to do is to put lambda plus half of this coefficient. So 2 divided by 2 is 1. So lambda plus 1. It goes inside of the bracket, which is squared. And then you have this minus 8, which you used to have. And then the second step, if you like, of that algorithm is to say that you have to take away whatever comes out of the bracket. So imagine if you have lambda plus 1, what number on its own will come out? Well, think about it. If you have lambda minus 1 squared, means it is multiplied by itself. Okay, so lambda plus 1 multiplied with lambda plus 1. If that's the case, again, lambda times lambda is lambda squared, 1 times lambda is lambda, etc. But 1 times 1 is 1. So we have whatever, 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 plus 1. So 1 is the number that will actually come out. So you have to balance it by taking that 1 away. And that is equal to 0. So I'm doing that, and it's called complete the square, because if I evaluated that fully, if I had this x squared now, that's plus lambda, plus 2 lambda, okay, and then I had minus 8 and minus 1, this minus 1 and 1 would cancel, and I would be left with x squared plus 2 lambda, lambda squared plus 2 lambda, and this minus 8, so I would have the original quadratic. That's why I had to take 1 away to balance it out. Now, so I've done that. As you know, 8 minus 1 is minus 9, and that's equal to 0. Now I can move this negative 9 to the other side. It doesn't contain lambda, so it's not important to me at this stage. So lambda plus 1 squared is equal to 9. Now this is squared, so what's the reverse of squared is square root. So I can have lambda plus 1 equals square root of 9. Move this 1 to the other side to find that lambda is actually minus 1 plus square root of 9. Square root means finding a number that will multiply itself and give you whatever is under the square root. So lambda is equal to minus 1 plus minus 3, because 3 squared is 9. Okay, but plus minus purely because minus 3 squared is the same as 3 squared. Okay, because minus times minus is plus. So anyway, both of these are equal to 9. That's why you end up with two solutions again. So you end up with lambda is equal to minus 1 plus 3, which is 2, and also, okay, that's a second solution if you like to think about it this way. So that's minus 1 minus 3, which is minus 4. So 2 and minus 4 should satisfy this equation. Just to quickly check it up, plug 2 inside. 2 squared is 4, plus 2 times 2 is 4. So 4 plus 4, 8, minus 8, it is 0. So yay, that's correct. And also minus 4 squared. Remember, minus times minus is plus. So anyway, you're doing 4 times 4, which is 16. So imagine if there is 16 there, then plus 2 times negative 4, that's negative 8, and that's negative 8. So it's 16 minus 8 minus 8, it is 0. So again, this is correct solution. So we have found it using complete the square. Final method, another approach that you can choose, which tends to be quite popular with students, I find, but it requires you to remember the formula, is the quadratic formula, finding delta. So if you remember delta, it is equal to b squared minus 4ac, where you have ax squared plus bx plus c equal to 0. So you can see that a is coefficient of x squared, then b, okay, let's make it a capital B, otherwise you can confuse it with a 6, apologies for my writing. So here you have coefficient of x and a number on its own. Then you apply delta to find if there is any solution. If delta is actually less than 0, then you have no real solutions. Okay, so no real solutions. If delta is equal to 0, then you have one solution, and ideally you want delta to be greater than 0, in which case you have two solutions. Well, you don't really want two solutions, but hopefully you know what I mean. You have these three scenarios depending on what delta is. And then what you do with the delta is to find that actually the solution to your quadratic equation is negative b, so negative coefficient of x, plus minus square root of that delta over twice coefficient of a. So let's just see how it pans out for this particular problem. So what do we have here? Clearly a is 1, there is no number in front of lambda squared, so a is 1. Let's just write it up here for reference. Okay, so a is 1. What is b? B is 2, the number in front of lambda is 2, and c is negative 8. So negative 8 is my number on its own. So a, b, and c, plug it into the formula for lambda. Lambda, pardon me, it's delta, of course. Delta is equal to b squared, which is 2 squared, minus 4 multiplied with 1 multiplied with this negative 8. So here we find 4 minus 32. So minus 32 means plus 32 overall. So 4 plus 32 is 36. And therefore lambda is being found by having minus b minus 2 in our case, plus minus square root of delta, so which was 36, and that is 2 multiplied with a was 1, so just 2, and you find that lambda is equal to minus 2 plus minus 6 over 2, 6 because 6 squared is 36, so I'm just evaluating square root of 36, and that points to our solutions from before. Minus 2 plus 6, that is that is positive 4. 4 divided by 2 is just 2. And also, if that was a minus 2 minus 6, which is negative 8, negative 8 divided by 2 is negative 4. Exactly what we had before, which we actually double checked, and these solutions are correct. So 3 methods. Try to learn all 3 of them, but settle for one to bring to your test 1. So that's it in terms of the content of the first week of teaching, okay, which is week 2 in our case. Further reading, I refer you to the book Mathematics for Engineers by David Croft, or Anthony Croft rather. Chapters 1 to 5 provide a nice guided introduction into all of these topics and more that probably would be beneficial to you. You don't have to read all chapters, obviously, just try to scan through them, look for extra exercises. Because something that I didn't mention in the introductory video is that this book in particular has loads of exercises for you to have a go at. Exercises and solutions at the back as well. Available as an ebook, also plenty of copies in library, both in London and Birmingham, so no excuse for skipping this. So have a look at this, rewatch this video if you like, look at the forum as well for any activity, and post any questions in there, or via email if you like to keep it a bit more private. Thanks a lot for watching, see you in the next video.